The City of Regina went to all of Canada to pre-qualify contractors.
Instead of just a race to the bottom with as many contractors as possible that show up at the tender visit.
Making sure that the companies that they are contracting to do the work are the most qualified to undertake the work.
Award process was based 70% submission, technical aspect, and 30% price. That's not typical. The history of the stadium was very important to the City of Regina.
They actually had football games dating back to 1914. The East Stands was built in, I think it was in the 1930s, somewhere in there, and they started with the concrete structure. Later on, they built the West Stands, which was a steel structure. They're so passionate about their stadium and their team, and we wanted to make sure we were bringing that same passion level. Pre-qualification came out in early May. Early June is when we found out that we were pre-qualified.
So it was out in Regina, so we had to coordinate our men, our equipment, getting that all out there, getting things staged, and also the weather. Working out in Regina in the winter isn't always the easiest conditions.
We really needed to be aware of what our out-of-town costs would be.
There's other unique things, like we had to consider hazardous materials, neighboring communities, vibration.
There is a street that runs right along the north side of the stands, and there's a park there where kids play. So we had to make sure we're taking that side of it down properly, as well as the west side, to make sure that we were looking at the whole project. We have done the stadium before. We demolished the Hamilton Tiger Cat Stadium.
The Regina demolition project had a larger scale to it. The building was significantly larger and higher.
The seating capacity held 33,000 people. If you compare that to the Air Canada Centre where the Toronto Maple Leafs play, that's a seating capacity of 18,000.
Either way, it was able to be completed with more conventional high-reach demolition equipment.
130 feet, you can't just use a regular machine.
Structures that high, sometimes it is an option to use blasting, explosive demolition, but the city only had a mandated requirement not to use that, and we followed that.
About a 25-hour drive from our home, Hamilton, Ontario. To get the ultra high-reach equipment out there would have been very expensive. There was none in the province locally that we could hire on.
We talked about a few different ways of doing it, and then Aaron suggested, what if we just pull it over?
Walking through some of the ramps, kind of assessing the structure, how we thought we could take it down. Just looking at the front of it, we kind of noticed that the front stands were almost a completely separate structure from the rest of the high stands.
So we thought, okay, well, we have to come up with a way to be competitive on this project.
Just kind of looked at each other and said, why don't we just try a cut-pull method?
City of Regina had, as part of their tendering process, suggested that they would like to see a really high quality of submission or a response. They said, the better the submission to the 3 pre-qualified contractors, we'll give you a $10,000 honorarium. We thought, you know what, let's use that money and put it to what they're looking for. We want to make sure that we're giving them the best information, or we want to give them the most information we can.
When Will called me and said, we have this project that we're bidding for, and it's judged mainly based on the technical aspects, and therefore I think you guys should be partners with us on that, I felt right then that we had a good match.
Every other bidder out there could show the client what they had done. Along with ASI, what we could really do is show them in a graphic way what we would be doing.
They explained to us their idea in brief. They want to do part of it mechanically, and the rest of it they want to use a cut and pull. We decided to build a simplified two-dimensional model
to verify just the concept that if we remove a part from this structure, the building will actually tilt and then collapse.
To show the client how it's going to happen, we showed how the mechanical part is going to be done, and then the cutting of this part and the pulling, and how the structure is going to tip over.
There was roughly, I would say, 6 to 8 weeks between submission and notification. After that, the process moved really quick. They sent me an email.
He sent an email out to all the team that just said woot woot.
High-fiving and like, sweet, we got this job. Now we gotta get to work.
For the planning stages to come up to talk with the estimating team, and that included the project manager and also myself as a site supervisor and health and safety team.
They informed us the scope of the work for the project.
Oftentimes we'll have one way of doing it, and we'll say, this is how you're going to do it. And the project manager or the site supervisor is like, well, yeah, but I think we need to tweak this or tweak that this time, because we had spent so much time preparing. They all looked at it and they're like, yeah, this is going to work. Let's go.
So next steps, we're actually talking about the workforce that would be there.
It's not like you can just jump in your truck and go out there.
We sent our main demolition crew with a supervisor and operators,
including myself and all my team members that actually do the demolition part, because we all work very closely together and we could be more efficient.
We were able to coordinate and use some of the local trades, which is always our preference.
Some of the fencing, vibration monitoring, some of the engineering, some of the welding.
That was required for the controlled collapse, where we had to add additional beams.
Local rigging company removed a bunch of the salvage items. A cutting crew as well that operated the torches.
We also had a subcontractor do the capping who was familiar with the City of Regina's requirements.
So we used Volvo high-reach demolition equipment,
Bulldozers, rock truck.
excavators with shears, breakers, pulverizers.
They started, like I said, on the ground first week of September, and the pull was planned, scheduled for October 27th.
With the City of Regina, we had an open house, and they went through all the planning and how everything went, where neighbors could attend.
The stadium, similar to the Hamilton Tiger Cat Stadium, it's right in the middle of a residential section of town. There's all these houses. They're not new houses, they're older houses, so they're a little bit more, I would say, brittle. We had to account for the park across the street on the east side, a train track running to the south side of the site. All of these things we had to take into consideration.
Neighbors are always a concern on all job sites, and I think it's about your early stage planning on how you're gonna keep their concerns to a minimum, and usually it surrounds noise, dust, and vibrations.
We also completed surveys of the homes in the area.
There was not really any concerns for any of the neighbors for dropping, and then the only concern we had, and same with ASI, was vibrations.
We had to set up vibration monitors around certain points of the site.
When you're dropping a 130-foot building in excess of about 350 feet long, of course there's vibrations concerns.
So Jeremy and Kyle were out there and they were testing the soil. And they took their bucket with the excavator and they tapped the ground, and it was just a swamp. The neighbors from the house nearby came out. So what are you doing? Why are you making so much vibrations? What's going on over there? Right away we realized there's going to be an issue with that.
The soil makeup in Regina on that site was a little less typical from what we're used to out in Ontario.
We had to find the chemical composition of the soil, which we were able to do. The city had it on record. They took that and combined it with the actual weight of the structure.
They had ran numerous models to confirm that the vibrations that it would create would be well within the allowable limits.
We also constructed a berm of broken up demolition debris to absorb some of the impact of the stadium hitting the ground. We were happy to see in our modeling that this would mitigate any major impact on the surrounding neighboring homes.
The City of Regina, one of their key things was the waste diversion. They didn't want to see all of the material ending up in a local landfill.
We always do our best effort to divert as much material from landfill that's possible.
We had presented to them a solution which was recycling pretty much everything.
In this specific demolition project, we were able to divert 98% of the waste. The steel, concrete, brick, wood was all diverted from the landfill.
To work with the engineers, we had to give them all the information that we had on the building.
We sent them drawings, we sent them pictures, we talked about the height.
And we also brought in the engineers directly to the site to walk the site as well. Because you know there's something powerful about walking around a structure and underneath a structure versus looking at drawings on a piece of paper.
We were able to see that there are some components of the structure that we did not include in our model, such as the additional weight of the scoreboard and some of the additional walls that were there added at some later stage and did not exist in the drawings.
We reviewed the drawings, verified on site the actual sizes of the beams and the structural components of the building, did a yield analysis on the steel at various locations throughout the building to confirm the structural component or the makeup of the steel.
The biggest challenge was coming up with a balance of the amount of cutting to be done.
Take in mind the wind speeds.
We decided that we're going to go with a design wind speed of 100 kilometers per hour.
In Saskatchewan, they have very high winds all the time, constantly. So that's a concern to us while we do the cutting. Once you get a building down to that size of structure and take away some of its support, wind load is a factor.
If a storm of a strength of 100 kilometers per hour hit the structure after it had been weakened, it does not collapse prematurely before the actual demolition date.
And ASI was very helpful on letting us know how much to cut for the wind that we projected over time.
Budget contacted manufacturers for the equipment that they're planning to use and obtained the maximum pulling force that can be achieved using the equipment that they had available.
And then we started playing around with the modeling to see if what we hoped would happen would actually happen.
We had to use a factor of safety to make sure that on the day of the pull, when you start pulling the structure actually comes down.
Once we opened up the building a little bit, we walked the building. They laid out the marks where the cuts were.
We have here a V cut on one side, and then there is a flat cut with shims on the other side.
And then they had a good feeling of the building too to see what had to be removed.
Using this model, we are able to find the actual pulling force based on the weakening that we are going to do to the structure.
The ASI basically ran it at several different scenarios.
Based on experience, we come up with an initial scenario for the amount of weakening that's done. And based on this scenario, we can get the pulling force. It's 60 kips, for example, in this case.
They cut a beam here, you cut a column there, exactly what type of cuts they had to do. They ran certain scenarios. When you cut it this way, it wasn't going to fall.
Because 60 kips is just too high, we need a smaller force. So we repeat again with more cutting done to the structure. And this time we have a smaller pulling force, 45 kips.
They had a look at it and they said, you know what, this is the way that you can do it.
Based on the model, we could find how the structure is going to land and the exact dimensions of the debris field. And then we superimpose those results from the model on a Google Earth image of the site, and we were able to say, okay, this is how far the debris is going to extend. And based on that, in coordination with budget, we will say, okay, this is the exclusion zone. Nobody should be in this area. This area is only accessible to the people who are working on the project. The green areas are the areas where the public would have access.
Once we had confirmed the final analysis from ASI on the controlled collapse and the structural members that needed to be removed, we began the demolition on the west side, removing all the non-essential components.
We agreed with them on an additional safety measure of installing some additional bracing that was not in the structure that we added and be removed at the very last day before the drop, and it had to be something that they can remove easily.
Basically demolishing a large portion of the west stands, leaving the higher section remaining.
Which beams are going to be removed and in what sequence.
I had to tweak the plan a bunch of times on how we would execute the weakening of the structure.
Coordinate that with the engineer on site.
To follow a specific schedule and a specific sequence of cuts. If they changed any of the sequence, then the structure could have collapsed early.
And ASI gave us a really good detailed plan on what to remove.
Prior to collapse, we had to remove the front section of the west stands, the lower section, so we were able to remove all that with traditional demolition, as well as the pedestrian ramps on the backside.
There was line B, C, and D. That was the remaining section of the building in columns in about a 20-foot section, so the building could collapse and drop that 20 feet.
October 27th, the Rough Riders were playing at their new stadium. There was a game scheduled for that night. We thought we would have this go during the day, and then people could go right from this to watching the football game.
And then the day of, we had to do the key component cuts.
For the steel structure was prepared by Torchman. There would be a series of cuts put along the back of it to loosen it.
Cut all the columns up to the end in here, up to the end of the web. Before we actually make the pulling, we cut the last web.
We hooked up a cable to the pole line, and we used two 40-ton excavators to do the pull of the west stand.
One big pull and the whole thing would collapse. It was very close. There was a few little things that were maybe just a little not exactly the same, but
I think we used a little more pulling force because we used 2 excavators and they called for 1.
The actual collapse was very close to the simulation. There was a slight deviation.
Instead of a gradual pull and collapse, it was kind of like pull it out and it dropped a bit and then it collapsed.
From what I can tell from the simulation and what happened, it was very close.
Would definitely do the cut and pull method again. I would worry less. You know, the day before the pull, I had ASI out there, had their engineer, and I said, I don't know, it looks like there's a lot of steel holding it up yet.
I told him, don't worry. Everything is going to work according to the plans that we have developed, and We have done our homework and we are sure that everything is going to work just fine.
Not every project requires this type of demolition procedure.
I wouldn't change anything. ASI did a very good job on prepping that job.
We definitely would use that if the project requires it.
Well, obviously the highlight of the project was the west stands. It came down beautifully.
It was really a great experience and a great moment, feeling even the vibrations really shows and validate the work that we have done together to achieve this successful demolition.
Spent all this time and you're prepared for it, and then just to see this big structure just before your eyes crumble.
You know, to see that structure that's 130 feet high, 400 feet long come tumbling to the ground, it was pretty exhilarating.
Seeing the reaction of our team, and it was like, yeah, we did this.
And everybody was like screaming and hugging, and at that time I felt it was like a family.
If you're in this business, that's what you like to do, is drop big buildings, and it was really fun.
ASI has done a number of projects similar to this in the past and used their modeling software to complete that work. So there was definitely an extra level of confidence that was provided to the client, the city.
I really admire the accuracy and the attention to detail that Budget had in performing the work.
Recommend them to other people, maybe not before bidding on a project, so we can use them.
They are very dedicated in getting the demolition safely and accurately.
Very good relationship that we had with them.
And I would use them 100% all the time.
I really like the team spirit in this project.
Their whole team was actually really good.
That resulted in a positive outcome.
Cool to see how you can use technology to eliminate risk when it comes to the actual work on the site.
The things I think that we can take away and that we're probably most proud of is that through this large demolition project, we had 0 lost time injuries or incidents on site. For us, that our guys are all going home safe and no one was injured is a huge success.
Yeah, everything came in under budget as planned. It was well executed.
The more challenging the job, the more interesting your work is. Often we think that we're limited to certain areas within our profession. The more you think outside the box, you realize how much our team is capable of doing.